multi twist in there, or?
I will have multiple components, and then depending on the audience wishes, I can focus on a couple of them.
Okay. So actually, no, Jakarta micro profile has open telemetry specification. More about these meetups is those who are not new attend those talks a few times. So you see this slide quite frequent every event actually. So these meetups are run by community for community. So to make it success as it is right now, we need your help. If you have anything to share, doesn't matter, it's small, Java related, not Java related, you do some, I don't know, well, pet project at home, just let us know. We want to hear about it, yes, because without speakers, this at some point it will die, yes. And the session is recorded, yes, so you see this small device here. If you don't want to be recorded, just try to avoid. So the main purpose of the recording is for the speakers. We have experienced one, so probably they don't need feedback. But we like to give the speakers feedback about the, here's the recording, look, watch, maybe you can improve on something. But we will have a channel. We don't want to really say too much about it because we don't want to make compete with, for example, VJAC or even, we want to people come here, not to watch them at home, yes. But I will share with you on the video, okay? So yes, please scan or go to this address and submit your session. You don't have to be a professional speaker. I'm not a professional speaker. And yeah, this is a great opportunity for you to actually improve on that. That's why I actually created these events, yes? Feedback, another one. Please provide feedback. Please, again, I will repeat what I say again. Without feedback, we won't make better those events, yes? And one of the feedback was actually, can you provide the link to this? Because some people don't like QR codes for no reasons. Here it is, from your feedback. Yeah, and another one very popular is like air conditioning, yes? Like some people say, oh, it's too hot. So other people say, oh, it's too cold. I don't know, you have to decide what you want. The event supporters, RecWorks. RecWorks was actually one of the founders, founder of LGC by Barry, who is also the owner of RecWorks. It's a recruitment company, great to work with if you're looking for a job or looking even more in this market to hire people. Let me know and I will contact. They're great to work with. I really recommend. And Couchbase, our host, again, we're grateful for having them. They are great. They even offer some prizes to win. So I know this will be more popular than my feedback form. So scan this and you can win those genius over here. And these are our sponsors. This is sponsor for our community. They basically pay some money that we can, for example, like contribute to open source. There is costs related to that. So we are grateful to have them as well. And that's enough of my rambling, I think. Yeah, thank you. And now I will, Georgina, yes? Yeah, Georgina will tell a bit about Couchbase, yes? Thank you. Any questions to me? I thought people will ask where I can find that feedback form. But no.
Where's the cloud button? Remember what we did just now?
This is give us a second. Hey.
Okay, thank you everyone for coming. As was just mentioned, I'm going to give you a quick introduction to Couchbase. So first of all, if you need the bathroom while you're here, it's just past the door that you came in through, opposite the lifts. There are drinks at the rack, and we'll have pizza coming for around halfway through the session. So I'm going to run you through what Couchbase is. It is the developer data platform for critical applications in our AI world. So what do we understand about the requirements of modern applications built today, and what have we learned from our customers? So on the customer side, there's a few key requirements. They demand great experiences for the end clients, whether that is having a personalized experience through the use of AI, or access everywhere, whether you're on your laptop or trying to use the application on the tube without good connectivity, have that application be available anywhere and everywhere. The Couchbase users expect to be able to develop quickly for their applications using their existing skills, and avoid data sprawl of using lots of complicated different technologies and having to understand and piece together all of them. And finally, they expect to be able to deploy efficiently on any platform in a cost-effective manner. So what do modern applications look like? Many applications today, as I'm sure you will all be aware, require AI capabilities, whether that is using vector search for semantic or similarity search, using LLMs to build chatbots or agentic applications. Modern applications will also have thousands or millions of users, and to go with that, a huge, huge amount of data and really high requirements for performance of that application. They might also require different types of platforms for deployment, whether that is on the web or mobile applications or support for IoT devices. Finally, there will still be some existing requirements that match the legacy type of applications. That might be more rigid data control, ACID transactions, storage efficiency, and consistency and integrity. So with that in mind, when it comes to modern applications, why do companies choose Couchbase? There are 4 key things that we see in the vast, vast majority of our customers. One key one is performance. Performance at scale, whether you have just a few users or millions of users across huge amounts of data, providing really, really fast data access. Couchbase is incredibly strong when it comes to performance, and really that's the bread and butter of what Couchbase can achieve through a memory-first architecture and active-active clustering between clusters and within the nodes of your cluster. Secondly, flexibility. Whether that is flexibility in terms of how you deploy, self-managed on bare metal or Kubernetes, private cloud, public cloud, with the versatility that is offered through JSON documents, and the flexibility of the data structure while still being able to query using SQL++, so leveraging those existing skills that you might have from working with relational SQL, and additionally, that broad platform support for vector search. Thirdly, mobile and IoT applications. Couchbase across the entire platform supports deployment in the cloud and to the edge, meaning that any users that have or are using your applications at the edge with worse connectivity or more unreliable connectivity will still be able to use their applications through the on-device storage and peer-to-peer synchronization, meaning devices can replicate data between each other even when there is poor or no network connectivity to the central cluster. Finally, simplification. Taking those excessive resource usage requirements from antiquated designs and building lower cloud and operating costs in a modern database through multidimensional scaling and optimization of hardware depending on the different services that you're using. Let's look at a couple different use cases. One key one is LinkedIn. So when we're looking at the performance side of things, LinkedIn do over 10 million operations per second across hundreds of millions of users with a really large data volume. So they use Couchbase for key value access and for caching, and they're able to get great speeds across those millions and millions of operations per second. On the other side of things, we also have that mobile and edge use case with Carnival cruises. So every person who attends a Carnival cruise is given an ocean medallion that stores data about their preferences and can offer them a much better end customer experience through that connectivity provided at the edge. And finally, I'll talk quickly about Domino's Pizza, who use Couchbase for operational analytics, meaning they can perform real-time analytics without any complicated ETL process by using the broad platform of services provided within Couchbase, supporting both operational and analytical use cases. So looking at this, I'm sure we've all seen an architecture that looks a little bit like this, where you're using lots of different technologies or services to achieve particular functionalities, whether that's Redis for caching, another database for vector search capabilities, bringing in another tool for full text search, then trying to include something if you want to push your application out to be supported on mobile, while also keeping a NoSQL or relational database at the core. There's a lot of complexity that's introduced here, whether that is through cost or security vulnerabilities of working with multiple different technologies, or the financial cost of licensing all of these, or the cost that is incurred by developers needing to learn and understand all of these different technologies to be able to use them to their full extent. So Couchbase aims to encompass all of these in a single platform. So as I mentioned, Couchbase has an integrated cache and is a distributed document database. So those two things are kept at the core, and that's how we're able to achieve great speed and great performance at scale through that integrated cache. But over time, we've also built out lots of additional functionalities on top of that, whether that is SQL++ for querying, or full text search for natural language or geospatial or vector search, or columnar storage for real-time analytical querying without any ETL. If there is anything here that you're interested in or you think might be relevant to an application you're working on, please feel free to come and chat with myself or any of my colleagues at the back of the room during the breaks today. And I'll happily expand on any of this, as there's a lot here and I don't have time to go into all of it right now. So at the end of the day, how is Couchbase architected for your modern applications, whether or not they have AI requirements? So one key thing is that there is no requirement for an additional vector database. Couchbase supports vector search natively, whether that's in the cloud, on-prem, or even on your offline first mobile applications. We have proven speed and flexibility with many of our customers using Couchbase for key mission-critical applications, and over 30% of the Fortune 100 using Couchbase for mission-critical applications. We have vector search across all of our products, whether that is on-prem, in the cloud, or on mobile or IoT devices. Above that, we also have an existing broad platform of capabilities, whether that's your SQL++ querying, support for graph querying, real-time analytics, full text search, geospatial search. There's an existing strong broad platform of capabilities. And finally, other ecosystem integrations. So these are just a couple of the AI-based ecosystem integrations, but we also have integrations for many other different technologies as required. So as mentioned, we will have a raffle at the end. We have here a speaker and some pop heads. So if you want to enter that, there's a QR code here, and there are also a few printed out scattered around the room. So feel free to scan that and enter now. Just give you a moment to scan that. And finally, just some other next steps. Like I said, you can come speak to myself or any of my colleagues, but we also have a meetup group, Discord if you want to ask any questions, and a free Capella tier. So if you want to actually have a go with Couchbase, we have our managed service Capella with a free tier, and you can also download the community edition locally and run it on your own laptop, whichever you would like. Thank you all for listening briefly, and I hope you enjoy the rest of today's session.
Oh, it worked. Okay. Okay. Wait, it did work. Now it's no longer working. Do I need to do magic on the remote again? Okay. Come on. Go. Yes. Okay. Hi everyone. My name is Howie, and the title of this talk is about Java build tooling could be so much better. About myself, I'm open source like JVM DevTools developer. So my prior work at Dropbox, Databricks. Right now I'm on sabbatical, so I haven't been working for a while. But my specialty has always been in kind of things like dev environments, build systems, CI systems, and a lot of stuff on the JVM. Last job at Databricks was all JVM. Open source work is all JVM as well. Now I'm just traveling, and that's why I'm here. Thanks, Marcin, for hosting me. So this talk will have 4 sections. We'll talk about, can Java build tools be better? Like where are the areas for improvement? We'll talk about NIL, which is one of my open source projects I've been working on, kind of on the side, and why it's interesting and what kind of abilities or capabilities it shows that traditional JVM build tools have not been able to give you. So maybe for the first thing, like, can Java build tools be better? So who here uses Maven or Gradle? Everyone. Who here uses something else? What do you use? Gradle. How about anything other than Maven or Gradle? Any Bazel people? Ant? No. Pants 2? Buck 2? No? Okay. So yeah, everyone basically uses Maven or Gradle on JVM. I mean, at Databricks, we use Bazel. That was one of my team's responsibilities. But many of these JVM build tools, I think people use them, but people don't always love them. And they don't always achieve like the performance, ID support, and ease of use you expect from the Java virtual machine. Like, use Java, right? Java is really fast. It's great IDs, like best IDs among any language, and it's really easy to learn. People learn Java in school and they are done coding in the first like few hours. And yet you can learn Maven or Gradle, and it's a bit more difficult than that. It's not so fast. ID support's not great, and we'll see like some details. So first is things like performance. So Java-C actually compiles surprisingly fast, more than what people expect. But the build tools don't always show that. So for example, if I pull up my the Netty code base, let's see if I can go to this, make this bigger. So over here, on here I have Netty, and if I compile Netty using Maven, let's pull this up. It's about 500,000 lines of code. This is just an example code base. And it takes about 50 seconds. So you may ask, like, this is about 10,000 lines a second compiling in parallel. Is that good or is that not good? Like, what's the benchmark here? One way you can measure that is we can try and minimize the example, right? Like, let's say we compile a single module using Maven. So Maven clean compile like the Netty common module. So this is about 29K lines of code. And you run it, it'll compile in about 4.5 seconds. So let's see if the previous example is done yet. So it's still compiling. Give it another few seconds, it should be done. This is in parallel using as many cores as it can on my 10-core MacBook Pro, in fact, fancy M1 processor.
How much latency is because of the velocity?
Probably not a lot. I mean, you mean the logging, right?
Yeah.
Yeah. So this is using the built-in terminal, not iTerm. So it's pretty fast for logging. But yeah, so here's about 50 seconds to compile all of Netty. If I do clean compile a common module, it takes about, that was a clean is done. Now it's actually compiling 174 source files. It took about 4.2 seconds. So that's like the baseline, right? But what if we actually look at it without Maven? So you all know, like, you can just use Java C to compile stuff. It's a bit verbose. I made the class path here really small because otherwise I can't fit on the slide. But if you run Java C without Maven and try and compile the same source files in the common source main Java repo, subfolder with the same third-party dependency jars, all that stuff there, you'll see this compiles in about 1.5 seconds. 1.48, run again, 1.54. And some of you may know that this is the slowest the Java compiler can ever be. Like, why is that the case? Who knows? It's because Java compiler runs on JVM and we run it cold from the command line every single time. And you all know that JVM programs are slow to start up and they take time to warm up and get fast. And this is the slowest possible performance, and it's 3 times faster than compiling it in Maven. So to do a benchmark of a bit faster, I have a small script here, bench.java. And all this script does is it runs a while loop, and it takes in your command and arguments and uses the Java compiler to compile it in memory. So all Java JVMs come with this built in. People don't use it much, but it's there. You can compile it in memory. And you can run this script. Again, I'm going to use this Java bench.java thing with a long class path from earlier. And you can see it's over time this warms up. So you know how JVM works, right? Compiler notices common code paths are called often. It optimizes it, does inlining, various optimizations after inlining, and gets faster and faster and faster. And if I cut it now, somewhere now, we see that it's now compiling 29,000 lines of code in 249 milliseconds. So this is a clean compile, no incremental, all 175 source files still there. And it's compiling at 120K lines a second. So that's kind of the benchmark here, and that, you know, you can compile Java at 100K lines a second. Maven's giving you 10K lines, 6K lines. You try using Gradle, give you about 15K, maybe 20K. So Gradle's a bit faster than Maven, but it's still very slow compared to how fast underlying Java tooling should be. Java tooling should be able to compile the whole of Netty, 500K lines in 5 seconds on one core. That's how fast it should be. So there's a lot of room here to improve if we can surface the performance of the underlying Java platform. The next thing we're going to look at is ID support. So like everyone here loves Java IDs, right? You can jump around your code base very easily. If I pull up again, I'm going to use Netty again. I pull up any random source file in Netty. I don't know which one. Let's say this one. Maybe this one's not so interesting. Maybe this one. I expect to be able to jump to any identifier in this source file kind of recursively and see where this thing is used, where it comes from, what its documentation is, where its usages are, and all that. So all that's great. But when you try and jump around, for example, your pom.xml file, you'll see that although nominally you have ID support, right, the syntax highlighting, it knows comments and stuff, you try to jump around, it doesn't really know anything about your pom.xml. And this is fine if you already memorize what your pom.xml is meant to do, but if you don't know everything about your pom.xml format, then it's hard for you to learn. And some things you can jump to, like activation, but it just brings you to a signature. So it brings you to this XML schema definition, which you may be familiar with. You get a bit of documentation, but where's the code? Like, what does it actually do? What if the documentation is not enough? What if the documentation is out of date? What if I need to learn more? Something's behaving. There's no way to find out. And it's not just Maven pom.xml. If I open a Gradle project, maybe not this one. Let's use this one. If I open a Gradle project, this is a Mockito code base built using Gradle. You jump around and you find like there's no docs, and you can't. You jump to definition, you don't really find much. You can't find see where this thing is used. And for some reason, it's the same case with Kotlin as well. Even though Gradle Kotlin should have better ID support, Kotlin has good ID support. It also doesn't have good ID support for the build tool when you use Kotlin in Gradle. So that's like strange, right? Like your Java program should have great ID support. All your Java programs, even non-Java languages like Kotlin, Scala, all have great ID support, but your build tools all don't. It kind of just sucks. So that's the second point for ID support. The last thing I'm going to mention is ease of use. So like, Java is super easy language to learn. People learn it in school as a first language, but it's surprisingly tricky to make your Java build tools do things in a reliable and correct way. For example, let's take a look at this requirement. Save the project line count as a line count txt resource file at runtime. So it's a bit contrived and arbitrary, but it's no more arbitrary than many of the things you actually have to do, right? Maybe the custom bill of materials, you have custom deployment artifacts, and you always have something special in many projects. And you can't always find the plugin to do exactly what you want. So in Maven, this is not that hard. You can use the exec Maven plugin. You can set up a Go exec shell out to the sh shell, do this stuff. But it's surprisingly non-trivial, and it's a lot less trivial than it should be, right? Like the requirement on the top left is like first-year programming students should be able to do it 100% of the time in 5 minutes. And what you have on the right, you have doesn't work on Windows, must escape ampersands, genuine sources don't work. And the problem is not just that this isn't great, the problem is that there's also no really better way to do it. Like, what are the alternatives here? Like you create a Maven plugin to count your lines, or you have an AND script, or you have a separate bash script. All can be done, but I feel to me it's a lot less trivial than it should be given the requirement. The requirement is like 30 seconds, I should be able to bang this out. And this is not quite there. Gradle has different subtleties. So Gradle, you look at, this is an equivalent Kotlin Gradle script to count the lines. And getting it right is not that easy. It's doable. You can make sure you have your depends on input files, output files lined up, make sure your paths line up. There can be bugs, like there's an invalidation bug here, which will invalidate more than necessary. I don't know if anyone can spot it. Sometimes this line command will run when it doesn't need to run. I'll just give you 10 seconds, see if anyone can spot it. So I'm marking the input files as source main. It should be source main Java. So if I change the resource file, it'll unnecessarily reevaluate my line count. So this is a kind of thing where it's not rocket science, but it is kind of tricky and non-trivial. It's easy to get wrong. And you can do it, and people do it. But given how trivial this thing is, it should be a trivial build script. And it should not be so easy to just accidentally screw up, like the invalidation or the caching or other things. So that's the first section of this talk, and why I think maybe Java build tools can be better in terms of performance, ID support, ease of use, and to program. And let's go into the next section, which is about one of my open source build tools I've been working on called Mill. So Mill is an open source JVM build tool. It's a kind of a hobby project of mine. Now that I'm on sabbatical, I've been working on it more seriously. And it targets basically every JVM language, so Java, Scala, Kotlin. You can try to be better than the existing build tools in the ways that I mentioned earlier. So faster, easy to use, ID support, blah. It's not a big project. Like there's a few people contributing, few maintainers. It's widely used in Scala. A lot of people there like it, but Java not so much. Although there are some projects like this CGPO, what's it called? Connection Pool library uses it. So it's not that widely used, but it's usable. So a Mill build looks not that different from a Gradle build. So the build is in code, in this case Scala code rather than Kotlin code, but in the end it's just code. So here are this is an example build with object foo extends Java module. I have some dependencies with this syntax. I have a test suite nested within it. You can compile, run, test, assemble, run the assembly later. So far, just boring build tool stuff, and it can do all the boring build tool stuff. Things like Spring Boot can be done with a bit more work. So this is example configuration for Spring Boot, using your data JPA, time-leaf templates, web jars for your CSS and JavaScript, integration tests using test containers, Postgres or H2. I can show this one live. Let me pull this up. So here's my Spring Boot example. So here is the code config. This is adapted from one of the Spring Boot time-leaf example project to do MVC projects. I can run mill -- watch test.run background. See, now it's running Spring Boot using all this stuff. And if I go to my browser, which I'm going to open a new window so I can move over, I can go localhost 8087. Here's my Spring Boot app running. I can go and edit it live. For example, let's say I want to change a template to like to-dos hello. You can see it just picks up the change, reloads. So this is not like rocket science. It's just showing you that this stuff works in Mill. It's not just for Hello World projects. It does support these other bigger frameworks. And like people ask, like, what does it support? And the answer is it supports most of the common tool chains. So all your packaging frameworks, all your linting frameworks, all your publishing destinations, all the JVM languages, testing frameworks, and so on. And it even has some tool-assisted migration now, so you can load the Maven build-in, and it kind of works, although it does require some manual tuning. So that's Mill, and you just saw Mill do all the boring stuff existing build tools can do, so why do you care about it? And I guess, again, it comes back to the same reasons we discussed earlier. Maybe we can improve on existing JVM build tools. So performance, ID support, and ease of use. So for performance, earlier we looked at LJCCoychbae. Netty is built using Maven. It's a big open source project. For proof of concept purposes, we ported the build to Mill. So it's a 500,000 line code base, 50 sub-projects. Took about a day or two to port to Mill. This was before the automated tooling for migration. Now it would be easier. And we got it complete enough that all the tests can pass on both. So it's not just like hello world compile, but like we actually ran all the tests and fixed all the bugs in the configuration, this compiler flag, this runtime flag, and it works. So the thing we saw earlier with Maven taking 50 seconds to run the parallel clean compile of the Mill build, of the Netty build, we see that Mill only takes about 10 seconds to run it. And I can show it to you now. So if I go here, as I get out of Spring Boot, go to Netty, Mill, clean, and Mill compile all. So the first time I run it, it might take a bit more than 10 seconds. It's a JVM app. JVM apps take time to warm up and can be a bit slow the first time you run them. So first time it took 15 seconds. Next time it should take about 10 or 11 maybe, because it starts up a background daemon like Gradle does and keeps the JVM, the Java compiler and toolchain warm in about 10 seconds. So it's not just parallel clean compile, but kind of broadly across all the different benchmarks, like single module, all the modules sequentially, incremental compile. It's just much faster. And it's still not as fast as it should be, right? Like Mill compiles everything sequentially in 20 seconds. The ideal case should take 5 seconds, we saw earlier, just doing the math. So there is still like a 4x build tool overhead, but it's less than the 20x build tool overhead that we were seeing in Maven to do the same thing, clean compile it sequentially of the whole LJCCoychbae. Gradle, we did a similar comparison using Mockito. Mockito is built using Gradle. You all know what Mockito is. 100K lines of code. Again, ported the Gradle build to Mill manually. This was before the migration tooling. All test passing, and just use that as a comparison. So for Gradle, we're looking at maybe a 3x difference between Gradle and Mill. Again, compiling the same source files, say in the same submodule layout with the same lines of code. So it's not like we're doing less or doing different things, really the same stuff, just has some less overhead for some reason. So apart from compile, you all know that's not the only thing you do in your projects. So there are other performance things that are nice. Like watch and rerun is very convenient. You just save your IDE, just restarts on the background before you even click over to your terminal. Other things Mill has that's kind of nice is selective test execution. So for example, if you put a pull request, you can check out the main branch, take a snapshot, check out your pull request branch, and ask Mill, hey, help me selectively resolve what changed due to that pull request or that git diff. And Mill can tell you that because you changed this file, the test repo source root here thing changed, therefore test repo root changed, therefore resources changed, therefore this test needs to be rerun. And all the other tests do not need to be rerun, just as important. And you can ask Mill to run it and only run the tests that change on your pull request. So very handy for bigger projects where we often only touch one part of the code base and other parts are unrelated. You don't need to run all those tests and you didn't actually affect them. Incremental assembly jars are kind of convenient. So for example, building a big Spark submit assembly. I don't know who here has worked with Spark, but like you often need to submit these big things to your Spark cluster. In this case, a 200 megabyte assembly may take 20 seconds to build. If you're iterating on that, it's very annoying. Whereas with Mill, the second time you create the assembly after making a code change, it takes like maybe less than 1 second to build because assembly jars, which are zip files, can be updated without having to be recreated from scratch. And most people don't do that for some reason, but if you're just making one small code change, having to repackage your entire transitive dependency graph into your assembly jar is very wasteful and slow. And just taking the jar, copying and updating our change file is much faster, and that's what Mill does. Last thing that's interesting for performance is the Chrome profile. So every Mill command automatically generates a profile that anyone can load into their Chrome browser. So let me see if I can pull that up for you. So So just now we clean compile a netty code base. We see there's this mil chrome profile flag that just contains metadata on where the time went in your clean compile all. If I go to my Chrome browser, I go to Chrome ::: tracing. Who here has used Chrome tracing before? Anyone? So all of you who have Chrome, which is probably everyone, have this Chrome tracing UI that can be very conveniently used to visualize parallel profiles. So you can see here, just now we saw it took about 10 seconds to run netty clean compile. Well, here is the time where it went. Like we can see at first the CPU is well utilized, it got bottlenecked on common compile finished, other things kicked off. See microbench compile kind of took the longest at the end, holding up the whole build while everything else was done. And from here, we can maybe have some ideas of what we can do better. Maybe we can break up the micro benchmark compilation. Maybe we can do other things. It's not just for compiles, but tests and other workflows also get these profiles that are very convenient. Your deployments or building or packaging gets these profiles. So you can see what your build tool is doing. And again, you can probably do this using Maven or Gradle. Like Gradle, if you pay for Gradle Enterprise, you can set up build scans, upload it to the server and get a UI like this. But Mill just gives it to you very easily for free, so you can understand what where your time is going. In this case, 10 seconds may not matter, but a bigger build may take much longer and we want to speed it up. So that's the performance angle. The next angle we're going to look at is ID support. So some of you may ask, like, what's the big deal? All the build tools have ID support. But earlier, as we saw, like ID support for other build tools often isn't that good. Like you jump to something and you hit a brick wall. You have this stub of like Gradle like getters and setters where it doesn't tell you anything about the logic at all. Like this get JVM args with no way forward. So with Mill, it works a bit differently. Let me see if I can show it to you now. So on the left here is the Mill build for the Mockito error-prone submodule, and on the right is a Gradle build for the Mockito error-prone submodule. One thing you'll notice is that they both contain all the same information, which is expected because this module needs these Java flags, it needs these Java C flags, it needs these dependencies, so this information doesn't just disappear. Mill has to be configured the same way Gradle does. And it's all with the same configuration. So what's interesting here is if we start trying to figure out what's going on in Mill, you see that we get documentation for all of the things we ask for. So like Java C options, option pass Java compiler, fork args, any command line parameters you want to pass, the fork JVM under run test or REPL. And if, unlike Gradle where you jump to JVM args, you get nothing, Mill, if we go to, the ID can tell me, hey, you're overriding JVM args. These are just methods that you override. And you can, IntelliJ knows that you overrode run module, Java module, assembly modules version. You can see, for example, run modules version, see the default value, which is an empty sequence. So this is Scala syntax, it's a bit unusual, but you can probably guess what it does. Yeah.
I'm speaking here, yes, because you have decompile code, yes, if you actually download sources.
Yeah.
I'm not saying there will be documentation, yes, but it may be that there is a documentation.
Yeah, so you will get more if you download the sources, but
on yours probably, I don't know.
Yeah.
I don't know Scala, but it's probably the same. You have like the code without the sources. There is no comments in source. I mean,
probably, yeah. So I'm just using the default IntelliJ integration. I'm sure it can be done better, but this is the default that you download the project, you open IntelliJ, this is what you get. I'm sure if you can optimize it, you can, but I'm guessing many people also use the default. So I think what's more interesting than the documentation, which is like useful, is the fact that you can look at this and start tracing through the logic of fork args gets used by this runner method. The runner method gets used by this run background method and this run fork task method. This run fork task method ends up getting used in the run method. So just like what you do in your application code where you don't know what this thing does, you can look around to see where these values come from or where they're going. Mill lets you do the same thing in your build. And maybe you don't know what final main class does. Well, final main class comes from final main class here, which comes from final main class here, which then tries to run all local main classes, that then tries to discover the main classes using class graph. So class graph is as a class path scanner. And the details of this logic are maybe not so important here. But what's important is if you didn't know what forecasts does, or you don't know how the logic of your build is working, or maybe something's misbehaving and you want to dig a bit deeper, with MIL, it's very easy to dig deeper into what your tasks are doing both upstream and downstream. So you can say, where is this guy getting used? You can also say, who is it using and where do they come from? And you can do all of this in your IDE without having to kind of query it at the command line or dig through source code on GitHub. So I guess that's an IDE support demo.
Question about that?
Yes?
So you don't have to install a MIL plugin, you just install the Scala plugin.
Yes.
And then you have to associate .mil to Scala?
It should be associated in the latest versions of IntelliJ. Yeah, we have send pull requests upstream to add the file extension. Yeah, so it uses Scala, and as far as IntelliJ is concerned, it looks like any other Scala program, including all the jump to definition and stuff, which is why you're able to do this. Whereas Gradle, although it is nominally Groovy, doesn't actually look like your production Groovy code, production Kotlin code, and that's why you're not able to jump around as easily as MIL's Scala code.
But does that mean that any plugins and so on appear as just like your normal plugin library on the project view rather than, because that's one of the problems with like Gradle. You've got a Gradle plugin, you can't on the project view. Just kind of like,
That's right. So for MIL, you can see all the dependencies are in your external libraries list of IntelliJ, and this includes the project's dependencies. For example, these are the MIL libraries. Now I'm jumping around run module.scala. This is in MIL Scala library, but you can also jump around other parts of it. So it really treats it like a normal application code base. You're able to navigate it and manipulate like a normal application code base, understand it like an application code base. Okay, one more. So right now, the first class citizens are Java, Kotlin, Scala. Then there's some experimental support for Android and Python, JavaScript, but those are still a lot rougher. Yeah, but so all the JVM languages, and Android's a bit half-baked, and Python and JavaScript also a bit half-baked. But there are people kind of working on it because they use these languages as part of their monorepos or something. But for example, for Java, like Mockito here is a Java project. Netty, which we saw earlier, is a Java project we built using MIL. We also have this Arrow example. Arrow, I don't know if you guys know, is a Kotlin functional programming toolkit. We have a MIL build for it here. Again, it looks very similar to Gradle build, but using the same information, but with maybe a bit better experience. I'll move on. So the last thing we're going to look at is ease of use, like how easy it is to use this thing, not just to command line, but like you have to configure it, you have to figure out what it's doing, you have to tweak it to do exactly what you want. So the first thing is that MIL does a lot of things by default. We saw this earlier. So you don't need to find plugins quite as much as you would in Maven or Gradle. Like we have Palantir Java format just bundled because it's not that hard to bundle. So we bundled it for you and you'll download it on demand and you ask it to format your code and format your code. And same with many of the other things here, like annotation processing, all the different languages, all configured for you. Publishing all of it kind of out of the box and just say publish, and it goes to Maven Central. But at some point, you need to go beyond the pre-existing plugins because there will be things that are unique to you and your project. And what's interesting here is that while most build tools require you to find plugins or write plugins, in MIL you can just write your own code using normal JVM libraries to do what you want. So, for example, let's look at a Hello World MIL application that's a bit simpler than the one we saw earlier. Custom Java, here it is. Clear the screen, make this bigger. I might need to reload IntelliJ. Custom Java, let me just clean up IntelliJ, ask it to go back in again. As you can see, IntelliJ support is not perfect, and sometimes you might have to reload it. It's not a first-class citizen, so to speak, although it generally works. Come on, and you're indexing. Okay, great, it's indexed, so now it works again. So this is a hello world. This is like the minimal MIL Java config. You see there's an object full extends Java module and there's nothing else. It comes with default source folders, default resource folders, default output folders, basically all the same things that Maven or Gradle provide by default. So you only need to customize the things that are actually want to customize. Let's say we want to go back and look at our line count project again. I want to add the line count as a resource file here. How do I do that? So in Mill, you can define tasks, which are just methods. So def line count is a task. And they call other methods. For example, I full line count, and I want to look at the sources. You can ask IntelliJ which sources you want. Maybe I want all source files. And I call that method. Let's say I map it to file.path. I want to read the lines of that file path, get the length, sum them up. And here's our custom task. Maybe I add some documentation. Counts the lines of code in this sub-project. So now I'm able to run mill show foo.line count on the command line. See, okay, now it runs value 17. I can inspect foo.line count from command line. You see it captures all the useful metadata like the name of this task, the file name, line number, even the Java doc gets captured for you. Inputs are captured for you. So you can also inspect at the command line, even as well as in addition to inspecting it in the IDE. It's kind of the same thing you're looking at in both cases. So these 4 lines of code, I have a new line count task. I need to wire it up into my resources. So to do that, mill uses overrides. So I do override def resources. Again, this is just normal overrides like any other JVM application. So I can ask IntelliJ which one I should override. In this case, I'll use this resources task. Super.resources, and I want to write an output file. So there's this task destination folder. I'll mention more in a minute. But I'm going to write an output file to the task destination folder containing line counts as a string. And then I'm going to append a reference to this to the resource path. So task destination, what's this? So in Mill, every task gets its own destination folder. Every destination folder is unique, so you can always write things to task destination folder without worrying about conflicts. Don't need to worry, hey, did someone else override my generated source? Did someone else delete this folder? Did someone else override my file? Mill, you just don't care about that at all. You write to that folder, it'll get deleted when necessary, and it will not get overwritten by other people when we don't expect it to. So now I have this. I have a reference destination folder on the resource path. I can say mill show foo.resources. You can see that I have the original resource path, which is the foo/resources folder. That's the source resources folder. I also have this outfoo resources.des folder below it. So this is the task.des folder that we wrote to in the code. And outfoo resource.des has our line count.txt, which contains 17. And now if I do mill foo.run, you'll see that our little Java example program is able to read this resource file and load it and print out the value at runtime. So I think this is quite interesting because you look at this, there's no like boilerplate around like saying this is a build tool task and you set input files, output files, input task depends on, and all that stuff. And that's not because the data doesn't exist, but it's because Mill kind of tracks it for you. So when I call all source files here, Mill already knows that, okay, line count depends on all source files. You don't need to go tell it separately. When I say resources depends on line count, Mill just tracks that for you. And again, you don't need to do it separately, which is very, very convenient. So let's do a bit more. Let's say instead of going for a text file, I want the HTML file as my line count. So this is a bit like arbitrary, but again, this is just representative. Sometimes you want to do unusual things. Let's say I want to use ThymeLeaf to template this. So Mill doesn't ship with ThymeLeaf. Import all.ThymeLeaf here. IntelliJ will shout at me. And my terminal will also shout at me. It doesn't have ThymeLeaf in my build file. But Mill allows you to kind of dynamically, not really dynamically, but conveniently import using import third-party dependencies using this import $iv syntax. So you can say import ThymeLeaf, org.ThymeLeaf, ThymeLeaf 3.1.1 release. And now if I load this in my IDE, now IntelliJ is happy, knows ThymeLeaf exists. I can see it here on my external libraries lists. And I can start using it. So I can say I want the context. I want the template engine. And instead of line count, or in addition to line count, I want the HTML snippet task, which uses time leaf. So a new template engine dot process, and I need to give it a context. So I'm just going to create a context. So line count, again, this is plus line count. So I need to give it a context. I need to give it the template string. I'm just going to copy the template string here because it's a bit finicky to write out the time leaf syntax. And so now I can say mil show foo.html snippet from my terminal. You'll see that, okay, I made a mistake. This should be line count, not heading. Now I'll see that this HTML snippet task contains my line count as a HTML snippet. And if I substitute it in here, instead of the line count task for generating my resource file, like I'm able to generate HTML with a line count inside at build time and provide it to the application at runtime. So again, this is kind of weird and arbitrary. It's not the real thing you're going to do. What's interesting is that in doing this weird arbitrary thing, we didn't need to go hunt for a mil time leaf plugin or a mil line count plugin or write our own mil plugin. We could just kind of write the business logic that we want to do for ourselves using the libraries you're already familiar with. Like you may already use time-lapse in application code. You know how this stuff works. And we get to do this with full ID support and without any of the boilerplate that's often associated with like your Gradle custom task or your Maven like exec, Maven Ant plugin or Maven exec plugin in order to do stuff. So coming back to the slides. So again, just comparing the line count task without the HTML part for mil and Gradle, you'll see that the actual business logic is not that different. Maybe in this case, the mil example is a bit shorter. Maybe a Gradle example could be collapsed a bit using map and filter and sum rather than having this imperative for each. But generally, the business logic is not the problem here. Like if I ask a new grad to write this business logic in 5 minutes, you'll probably be able to more or less get it right. What's the tricky part is all this other stuff outside that's very easy to get wrong, and it's not so trivial to figure out when it is wrong. And it's the same with Maven, right? Like actually, both of these things contain the same imperative logic. Like just wrapping my bash snippet in an XML blob doesn't make the bash snippet any less imperative or dangerous or fragile. It's still a bash snippet, it's still hard to change and kind of sketchy. But I just put in XML blob, but the problem is still there internally. So whereas mil kind of embraces the fact that it is code, instead of making it bash code, you now have kind of check ID supported like Scala JVM code that can use all the normal Java JVM libraries. And you're not just like, plugging together bash commands anymore to try and make a build do what you want. So that's the ease of use angle, why I think mil is interesting. The last thing I'm going to touch on is how does mil work? Like everyone wants these things. Everyone wants great ID support. Everyone wants fast performance. Like how come Maven and Gradle don't have it? Like if mil can have it, why don't they have it? And I think a lot of it comes down to a few things. One is the idea of your build being just objects and methods. So in mil, your sub packages are just objects. This object syntax is a singleton in Scala. It's like the object in Kotlin or a singleton object in singleton getter lazy initialize in Java. And it extends a Java module, which is just an abstract class or interface with default methods. And like any other extension, you get methods with it. These methods call each other. And in mil, the object becomes the sub package config, and the methods become your build graph. And the build graph is made of tasks calling each other. So when I do things like, hey, I add a new method, line count, that calls source files, and I override resources that calls super resources that also calls line count. You already know how this stuff works. You learn override and super in Java 101. You already know how method calls work. And so you already know how this will affect the call graph and therefore the build graph. And what's interesting is once we have this build graph, we're able to do interesting things. Like we can say that, hey, compile in blue and line count in red do not depend on each other. We can compute them in parallel. We don't even need to ask the user what's parallelizable or not. Foo.assembly depends on both red and blue threads, so we need to wait for those to complete before we can create the assembly. We can assign each task automatic caches for you. So foo.line count is automatically cached in out/foo/line count.json. And no one else is going to use that file, only foo.line count gets that file. sudo compile gets both compile.json for metadata as well as a destination folder we mentioned earlier for the output files. Like build tasks often generate files, so they don't just generate metadata. So every build task gets its own desk folder. And these desk folders and caches never collide, which is very nice. So like assembly will never collide with compile, both its desk folder or its JSON cache. And lastly, once we have this graph, Mill is able to do automatic invalidation. So when you touch the resource folder, which is now super resources because you overrode it, Mill can see that, hey, I do a breadth first search in this graph, resources downstream needs to change, assembly is downstream needs to change, compile and line count are not downstream, we can just use the cache version that was generated automatically on disk for you. And what's I think most interesting here is that you look at the Mill config here, there is no code related to parallelism or caching in this Mill config. You don't see threads, semaphores, futures, executors. You don't see cache key computations, hashes, writing to cache files, reading from cache files, invalidating, deleting cache files. It's all done kind of behind the scenes for you. You just write your business logic here, which is usually actually quite straightforward. Like your builds aren't doing rocket science. But you guys write your business logic, and Mill will just take care of all the rest, like 99% transparently. Not 100%, 1% of the time you figure it out, but 99% it will deal with all the parallelism caching for you, even for trivial tasks like line count. And in this case, maybe it doesn't matter, line count is fast, but there will be cases where your custom tasks are not fast, and you do want them to be parallelized and cached and incrementally evaluated. So I guess in the high level of how Mill works is the builds are just methods and objects and methods calling each other. And because they are just methods, objects calling each other, you already know how it works. Like the Scala syntax may be a bit unfamiliar, but they see the same semantics as overrides, super methods, and objects and classes in Java or Kotlin. Extends, IDEs can understand it too. So you don't need a special Mill IntelliJ plugin. You just told Mill IntelliJ Scala, hey, Mill is Scala code, just treat it like that. It's able to work. And Mill handles all this other stuff for you, which is good in multiple ways. Like it means you don't get it wrong so that you don't get things which are not cached or parallelized because you're too lazy to, or some plugin author is too lazy to. You don't have to clean as often because someone screwed up their caching validation, which happens a lot in other build tools. I made a mistake and now it's not caching, or it's caching too much or something. And it makes life easier for you, which also makes it easier for you to make Mill do things. And for Mill's case, Mill is able to make use of that advantage to say, hey, we can spend our time doing other interesting things like selective test execution based on diffs, or like incremental assembly jars, or generating profile flags, rather than trying to struggle with making sure all our plugins are cached correctly in the same way, all our plugins are parallelized correctly with thread-safe data structures. So that's how does Mill work. So this is the last slide. I guess the long and short is, if you're happy with current Java build tools, hopefully this gave you a lot of ideas and maybe the ways that they could improve or opportunities that they could do better. So like performance, ID support, and other things can be a lot better than they are now. And I think this kind of proof of concept demonstrates it. If you're not happy with current Java build tools, hopefully Mill is an interesting thing for you to go try. Maybe your next side project, maybe you can try migrating one of your existing projects if you find it's compiling too slowly, or you find your caching and parallelism is not working, or you're having to clean too often. But it's worth a try. Again, it's not as mature as Maven or Gradle, but everything I showed you works. There were no tricks here. And if you try it and find issues, we can maybe make it better together and help improve the Java build tool ecosystem. And that's it. I think I'm done. Thank you. Time for questions? Behind? For Mill, yes. Yeah.
I just noticed you have plugins for the built-in project. I mean, like when I do my Gradle build, I normally just go to start the website. Is there like plugin available as well?
There is. It's not as rigorously tested, so I can't demo it right now. I know people have contributed it, but it's not like it's not tested in CI because it's IDE. So hopefully it works, but you'll have to try it out. Yeah, but when it breaks, people tend to fix it. So there is a whole bunch of code integrating with IntelliJ using build server protocol, and same with VS Code, which uses the same protocol. Both use the BSP. Yeah. So I think people made run, compile, test, clean, and other things work. And if you look at my Mill build, let's find a good example. You can kind of explore what your dependencies and your available tasks in this BSP panel, and this is like a standard like IntelliJ protocol that Bazel, Mill, and VS Code and IntelliJ and others kind of share. So it's still work in progress. It's not 100%, but it gets you maybe most of the way there. Yeah, I personally use the terminal everywhere, so I can't vouch for its effectiveness. Any other questions?
Question, comment, maybe, I don't know, because one, you say like Maven is super. I'm kind of like using now Maven, use Gradle in less extensive way. And for Maven is very opinionated. You do the things a specific way. For example, that's what we have now, like the source, resources, structure of the Java projects which everybody use. It's thanks to Maven. And again, I'm not very experienced Gradle user, but one of the criticism about Gradle was that you can quite easily shoot it in the foot. I would say, I'm not saying your idea is wrong or whatever it is, but I think it's even on steroids what you try to do it. Make it even easier to extend. Make it, do whatever you want to do in your build field. You even mentioned once business logic. When I had business logic in my build field, I was like, ooh, that's not the place where business logic should go. Yeah, so
That's baby. Think like that, right?
I mean,
Yeah.
It's a tool the same with the knife. You can kill someone or use it, but it depends in Maven. And it's not criticism about you. It's basically that I think Maven did a lot of good. It's different where we are with Maven. Maven has been created, I don't know, 2000, whatever. Yeah, so we learn a lot of lessons. Yes, but yeah.
Yeah.
That's my comment.
Yeah, I think my response to that is, I mean, one is that Mill does follow Maven in terms of providing defaults. So, like, if we go back to our example, like Mill project by default, there's like no configuration. It's just like any Maven project, right? It uses the standard source folders, resource folders, input tests in there and everything, and output folders, all that's normal. So that's, I think, a good idea that we did take from Maven. We don't force you to redefine everything like an Ant build. We have to customize everything from scratch. Versus Gradle, I think it largely comes down to a matter of execution. So if you go back to the comparison earlier, if you just look at this slide, like, I do agree that the Gradle project on the right makes it very easy Gradle on the right makes it super easy to shoot yourself in the foot. Like, this is extremely easy to get wrong. And like, we did get it wrong, and no one in this room could figure out what was wrong just by looking at it. And I think the Mill config makes it easy enough to get right that you'll probably get it right most of the time. You won't get your dependencies listing wrong. You won't get your caching wrong. You won't get parallelism wrong. I think those are the main ways that you often will screw up a Gradle build. Like, people don't actually screw up recursively listing files and getting the lines. That's like trivial, but it's all the tricky build tool stuff that is what you get wrong. And Mill kind of tries its best to hide all of that, so you cannot get it wrong. I cannot screw up the line count computation here. It's kind of structurally, that's just the way it is. So my hope is that although it is imperative code, it makes it safe enough that you can do it without screwing up, which whether it's true or not is an empirical question, but that's my hope for this project. Yeah. Over here?
When you nuked the idea file,
yeah,
right, was that using SVT to read your .mil file and rebuild the project from scratch?
There's no SVT here. IntelliJ reads
Sorry,
yeah.
I used the wrong phrase. But you nuked the idea file
Yep.
because you want to refresh the project. You want it to come up and see what's supposed to be. Was it reading your mil?
Yes.
Okay.
Yeah, I had to nuke the idea file because we still have bugs in integration. So sometimes IntelliJ gets confused. So once in a while, so sometimes if it gets confused, I have to whack it. And I'm working with IntelliJ guys to try and figure that out, but it's non-deterministic in IntelliJ. It's a bit difficult. Yeah, but it was only refreshing the IntelliJ integration. It was not refreshing the build itself, to be clear. So you run compile, test, run. That's using the Mill cache. It's only cleaning out the IntelliJ config that IntelliJ creates during this import. Yeah. It does have multiple passes, but the configuration step in Mill is a lot simpler than in Gradle. So yeah. So Mill, I guess the way you think about it is you define objects and methods, and that is your configuration step. So you don't have like a mutable state where you're like appending to something and then it's going to become something different later, and then at some point it changes again, which is what happens in Gradle. In Mill, you define it, and that's it. And maybe you override things, but if you override things, IntelliJ knows about overrides. IntelliJ can help you follow these overrides, and we can't help you follow the mutation that happens in the Gradle build. So yeah, it does have this two-stage thing, but the first stage is just a lot simpler than Gradle's one, and hopefully less error-prone. Yeah.
I think we have to finish the question. You can stop,
Okay.
During
Sure.
the break, because I don't know.
Okay. Cool.
So,
Okay.